Hello, I'm Jordan Wilson, and the three companies I researched are Imgur, Spotify, and Pinterest. Each of them use different tools and processes suited to each of their needs to achieve the same goal: uniformity and consistency with the least amount of server downtime. The first company I looked into the deployment process is Imgur. Imgur is an image hosting service with a user base counting in the hundreds of millions and getting 1.5 million images uploaded each day. Their service runs on three different platforms: the web, Android, and iOS. To help keep everything uniform, they had to streamline their deployment process. What they needed to accomplish was a way for them to distinguish between builds on their various platforms, to be able to run shell tasks to automate some of the building and deployment processes, and be able to connect to the PhoneGap build system to keep things uniform across the different mobile devices. To accomplish this, they use Grunt.js. An appealing thing about Grunt is that it allows developers to easily and quickly add multiple profiles that clearly distinguish it from the different platforms and different building stages. At the top of their wrapper, they fill the blank with the name of the task, and the name is passed to each task under that name. There is an option space where a developer can type in whether it's the development stage, testing stage, or the production stage. Not only does Grunt help them distinguish their files from one another, Grunt also has a plethora of plugins to help automate and speed up the build process. Some of the plugins Imgur uses is Grunt preprocess, which preprocesses HTML and JavaScript directives based on the environment configuration. This is what helps separates the web and mobile versions of the app. JS Hint, which validates their JS files, and CSS Min, which minifies their CSS to cut down on loading times. With all these perks, Grunt.js is a good option to consider in cutting down the deployment process. The next company I looked into was Spotify. They are a music service that runs on just about every system, including Windows, Mac, Linux, iOS, and Android. They primarily use Cassandra for persistent storage and have 7,000 servers in production. Spotify has recently updated their system and their deployment processes. They use the Debian stable repositories. Backporting was required to get newer libraries. Debian doesn't use the typical Python packaging. Any new developer who got hired onto their team would have to learn how to package Python inside the Debian packages, and then the system and on this system, full rollback was non-existent. They now use Debian Helper (DH) with Python virtual environment. This new system this new system still requires native dependencies to be installed, but the benefits include no more backporting of libraries or versions, code isolation, single package rollback options, and best of all, their development and deployment systems all use the same cross-platform setup. Spotify has an interesting way in how they conduct tests for different mobile devices, desktops, and web clients. They break their tests down into 7 different parts or stages. There are the performance tests, API tests, GUI tests, system tests, component test, unit test, and integration test. Developers will make a small app to be tested individually. Spotify uses a lot of different tools to help display their results. They use YEd to edit GraphML modes, GraphWalker, and Python GraphWalker, which generates test sequences Sicoli, which is an image recognition program, and Jenkins, which schedules and launches the test, to name a few. The results are graphed and sent back to the developers. This gives developers and designers a visual aid to see what is working and what isn't. These are some of the ways Spotify streamlines their deployment process. The last company I researched was Pinterest.com. They are described as a visual discovery, collection, and storage tool. When a user visits the site, the server tells the browser to load a JavaScript bundle, and that bundle is checked to make sure the version of the backend software matches the bundle. When they make an update to the backend software, they create a problem for their users. The way they handle it is they make different ports for different versions of the server. When they wish to make an update to their server, they will roll through 10 to 15% of their servers at a time, slowly converting them from the old version to the new version. The old version is pushed to a new port, and the new version takes its place. What they did before, when they wanted to update the server, was to force a page reload on the user's computer. This would create a jarring experience for the user and could even potentially lose the user's context on the page. Since Pinterest is an XHR based and only reloads the page when something is clicked, having both versions running at the same time fixes many of the problems they faced in their early days. What this means is if a user is online and the server they are on is updated, they will still have access to the old content, and only when they click on something will they be redirected to the port with the newer server version. They manage this by beefing up their web front end boxes from a C1 X larges to C3.8 X larges. This setup can not only handle more loads, but easily runs 64 Python processes, where half were serving the old version and the other half are serving the new version. What Pinterest wanted to achieve was this stealthy new deployment process. What Pinterest wanted to achieve with this stealthy new deployment process was a reduction in the number of page refreshes. With this new method, they have clearly achieved this. With this process, they can reasonably do more deploys throughout the day without users even noticing. And so here are my sources, and that's my presentation. I hope you all liked it. Have a good one.